28. Use the standard entropy data in Appendix G to determine the change in entropy for each of the following reactions. All the processes occur at the standard conditions and at 25 degrees Celsius. Okay, so in this case, we have CS2 gas plus 3Cl2 gas yields CCl4 gas plus S2Cl2 gas. Cool. We want to find the change in the entropy. Remember, the change in the entropy, change is always a delta value, final minus initial. But in this case, we want the entropy, that's an S. Now, since we're using standard values from an appendix, aka the back of a textbook, we're searching for delta S notch, right? Anytime that you see that notch in the upper right-hand corner, that just means standard, that they took the numbers from the back of a textbook, or standard values. So that's exactly what I did. I went to this Appendix G, or any back of the textbook will give you your entropy values for each individual component. So for CS2, it's 238.0, Cl2 is 223.1, CCl4, 309.7, and S2Cl2 gas, which is 319.45. Now, we could generally guesstimate if our delta S value is going to be either a positive or negative. Positive means that you're gaining in entropy. And remember that entropy just talks about disorder or the chaos of the system, right? And remember, gases are the most disordered. They're most chaotic because their molecules are bouncing all over the place, in the container. So if I look right across the board, I have gas, 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 and gas. They're all gases. So no change in state here. But if I just tally the amount of gases, I have 1 CS2, right? There's a 1 in front of here, and there's 3 Cl2s. So I have a total of 4 gases on my reactant side, and I'm going to something that just has, no coefficients in front. So I'm going to 2 moles of gas. So in this case, I'm going from 4 moles of gas, a lot of chaos, right? The more gas you got, the more chaotic it gets. So I'm going from 4 moles of gas to only 2. So I'm bringing it down a notch. And if that's the case, I'm lowering my disorder, lowering the chaos. So my delta S would probably be a negative value. Let's see if that's actually the case. What are we going to do with these values? Well, we're going to plug it into the formula, and that formula is this. Delta S for the whole entire reaction, that's what we're looking for. Rxn is reaction, equals the sum, that's what this little symbol means. The sum, aka just add the sides up. The sum of all the products minus the sum of all your reactants. So are these numbers going to be the same? Well, it depends on the balanced equation. For example, 223.1 or any of these numbers are all for 1 mole of the compound. But for Cl2's case, you have 3 of them. So you have to take this number and times it by 3. But for all the other ones, since you only have 1 of them, you take this number, you times it by 1, it's the same number. You take the 309.7, you times it by 1. That's the same number, but I'm just writing it here just to show you that whatever the coefficient is, that's what number you times it by. And then you got to sum them up. Literally, it's CS2 plus Cl2. So I have to take these two values and add them. The same thing for the products. CCl4 plus S2Cl2, so plus. Let's find out those total values now. So for the reactants, 3 times 223.1 plus 238, you get a total of 907.3 for my reactant side. And then for the total of the products, 309.7 plus 319.45, I get 629.15. Now let's just plug it in. Delta S for the whole entire reaction is products minus reactants. So 629.15 minus the reactant value, which is 907.3. And it looks like a negative number. We guessed correctly. Let's just see what that negative value is. Delta S for the whole entire reaction is, let's see, the 629 minus the 907. I see that I have only 1 sig fig after the decimal, the lowest value, so that's what my answer should be in. So this is negative 278.2 if we round it. So this would be joules per mole times Kelvin. That's the unit of a entropy value, standard. So there you go. Let's box this in. Let's make it pretty and be done with it. Okay. I really hope this helped you out. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel to help us out. Tell your friends, tell your classmates about this cool YouTube channel. I think it's pretty cool. Thank you so much for all your support. Keep on learning. Good luck on your future tests and quizzes. I'll be talking to you soon. Bye-bye.